How did it go with the buying of supplies? Were you able to order? Did they get delivered? Are you waiting on a delivery? Did you have any problems? Nothing I need to know. How many people have their paints already? How many people are waiting? Okay, good. I'll check again on Wednesday. I'm gonna try to see if we can start painting as early as next week, okay? Good, all right. So today is a pivotal day. It's a very important day because today we are going to transition from into a new palette. And so this is why recording this session is very important, because I've got some people absent and they're going to miss a whole bunch. To recap, we have been learning as much as we can, given the allotted time, everything we can about RGB. We learned that RGB comes in a total of 256 options. The primary colors are R, G, and B. I want to also stress to you that RGB is considered, is an additive system. What do I mean by an additive system? Anybody want to tell me? Why is RGB an additive system?
Because it's based on adding colors together.
And when we mix the primary colors together, what do we get in RGB? If we mix red, green, and blue together, we get white. That's why it's additive. And it's going to make more in a lot of sense in just a few minutes when I talk about the new system that you're going to learn, okay? So RGB is everything made with colors that are made with light. That includes projectors and phone screens and computer screens and TV screens and theater lights and cameras. Everything that utilizes light and colors from light is RGB, okay? We also learned that that hexadecimal comes from RGB, which also is a palette made with light. It's still additive. Hexadecimal is the computer code for being able to determine RGB colors from 3 digits to 2 digits, making a color identified in a total of 6 digits. 2 digits for red, 2 digits for green, 2 digits for RG and for blue. So it's everything made from light, RGB. Additive system, 3 primaries equal white. So I introduced RGB to you talking about Newton. And Newton, who had projected that beam of light through a prism, refracted the light through the prism, discovered the spectrum, and then also realized that color is part of the electromagnetic spectrum. And that there's a certain small portion of the electromagnetic spectrum that is visible to the human eye, to the naked eye. This is where we get color. And that the spectrum travels in wavelengths or nanometers, correct? Okay, so during this time, Newton's doing these experiments, and fellow researchers and scientists are coming to Newton's studio, to his laboratory, and they're sharing this information with him, and they're going back to their labs, and they're doing even more experimentation with light, with the electromagnetic spectrum, and it's all working great. I mean, they're learning lots and lots of things related to the spectrum, the electromagnetic spectrum, and to light and the color mixing of light. And it's perfect. It's not only, it's all scientific, but it's based on what nature, it comes from God. I mean, it couldn't be more perfect than that. So during this time, not only are there scientists working with color, but there are artists working in color. Now the artists come to Newton, not really, but to make the story interesting, and say the artists come to Newton and they say, hey Newton, this principle that you're doing When I mix red and cyan and RGB, red, green, and blue together, I'm not getting white on my canvas. Okay, I'm getting anything but white. What gives? What you are teaching here does not apply to me. And Newton says, well, I'm dealing with light. What you're dealing with is called colorant or pigment. Anything that's on an object is colorant. And so that means paint, dyes for coloring fabrics, and pigments for coloring materials. That's all colorant. And it's different. It's different, in totally different rules than it is with light. Okay? But how do we connect that stuff that Newton taught us and turn it into this structure of life? So the artists, and I'm going to tell you a little bit, I'm going to segue a little bit about talking to you about artists during that time period. To be an artist back then was very different, is very different from being an artist today. I don't know about you, but when I told my parents that I wanted to study art, they were like over my dead body. You know, I don't want you to be poor. I don't want you to be, unemployed. This is not a good thing. I don't like this. I need you to be able to be self-sustaining. I mean, every negative thing. But back then, if you were an artist, you were like part of the elite. I mean, you were, the commissions you would get included, doing people of stature, people with money, aristocracy, you were always invited to the best parties. You were part of this upper echelon of group. You were really one of these people that just were really considered of a very high nature and taken care of very well and all of that stuff. And the reason why I say that is because, to also be an artist at that time, you were not able to today, drive over to the Hobby Lobby or Michael's and pick up a paint or your colored paints. You were pretty much limited by where you lived, by the colors that you had were limited by where you lived. Let's say that I was an artist during the time living in Venice, Italy. And Venice is a great place because it was a port city. So the chances of my being able to get, a Prussian blue from a ship that's just come in from China or from India, a red, that's been imported from a different country is very, very, would be very good for me because of where I live. I have access to it. But if I didn't have access to this port city, I would be limited in whatever materials were available to me within my region. This would include, minerals, animal matter, plant matter, and to be able to make colors as an artist, again, I couldn't go to the store and just pick up tubes of paint. What I had to do was find the materials, dry them out if they had moisture in them, dry them out, grind them up into a fine powder, and then mix some kind of media extract into it, be it a linseed, an oil, or an egg tempera of some sort to give it the viscosity so that I could paint. So the colors that I was able to use were somewhat limiting because based on what was available to me as a natural material. Do you understand that? So what Newton was doing in light didn't apply to pigment. Totally different rules. Okay. New topic, and then I'll come back. During the holidays, Christmas in particular, you get invited to different families' houses or neighbors for Christmas get-togethers and meals and dinners and parties. And are you familiar with the ever-present Christmas sweater? Right? The Christmas sweater that has the knitting that's been knitted and it's got the pattern of the trees or the reindeer or the Santa, those ugly sweaters I'm talking about, right? You know what I'm talking about, right? Okay. Has anybody ever noticed when you take that sweater and you invert it, you show the inside out? What does that look like? Any guesses? It does not look like the front. It looks totally different, correct? It's almost like an alternate pattern, and it's not really a pattern, it just looks like a jumbled mess, correct? But it is not the same thing as the pattern. It's not even, if it's handmade, it's not even the opposite, the negative of that image. It's just a whole bunch of stuff, correct? Good. Remember the inverted sweater. So, RGB is what we know. Primary colors in RGB, and it is called additive because when I mix all three together, I get white. Okay? Here's where I test you. What colors do green and red make? Sorry? Do we need to go back to our color making? What color does red and green make? Yellow. Thank you. What color does red and blue make? You sure? And what color does green and blue make?
Cyan.
Cyan. Thank you. Okay. These are secondary colors, second generation of colors, okay? This we know. This we've got 256 options here, correct? Okay, so this is light. Now what we're going to do is we're going to invert the sweater, invert RG and B, okay? And instead of the red, green, and blue being the primaries, which the primaries are light, we're going to take the secondary colors, magenta, yellow, and cyan, and we're going to make those the primary colors of pigment. Another word for it is colorant. Now, again, these secondary colors are now the primary colors of here. And so, therefore, and it's an inverted sweater, therefore, I am going to call it subtractive process. Therefore, if I mix yellow, magenta, and cyan, what should I get? If it's the inverted sweater?
Black.
Black. Let's mix colors now. Yellow and magenta make RO, red, orange. Cyan and yellow make green. Cyan and magenta make V, violet. Let's go. This is our second generation of colors, or secondary colors. Let's make a third generation of colors. Yellow and red, orange make orange. Red, orange, and magenta make red. Magenta and violet make RV, red, violet. Violet and cyan make BV, blue, violet. Cyan and green make blue, green, BGR. Green and yellow make YGR, yellow, green. Third generation of colors. This third generation of colors are referred to as intermediates. If you, in some circles, academic circles, if you were taught color in high school or in science class, they will have you may have heard that the third generation, some people refer to it as as tertiary colors. I do not I use tertiary as a different meaning. The third generation are called intermediate. So you have primary, secondary, intermediates, okay? So this structure of the secondary family of light is now the primary colors of pigment, which is magenta, yellow, and cyan, otherwise known as MYC, M-Y-C, magenta, yellow, cyan, MYC. Okay? Do you see the inverted concept here? Do you see the structure? Do you see the relationship between RGB? Okay, so. My freeze, okay. Okay. I gotta wait till it freezes. So, this makes sense, yes? I have a question for you. Let me see this. Sorry. Tell me when that goes away. Magenta, yellow, and cyan, MYC, primary colors of pigments. When you were in grade school, when you were first introduced to color, what did your teacher tell you your primary colors were?
Yellow, red, and blue.
Red, yellow, and blue. RIB, R-Y-B. Why were you taught RIB and not MYC? Guesses.
They're easier to pronounce for kids.
They're easier to pronounce for kids? Is that your answer? That's your guess? Do you know that in Europe, children at the age of as little as 5 are being taught 3 languages simultaneously? Are you telling me that a child cannot understand magenta or cyan intellectually when they're learning 3 different languages? Are you saying that children are that stupid? What else? If I were to say, everybody get up, we're going to the elementary school and we're going to barge into that, first grade, kindergarten class, and you're all going to go in with me as thugs, and I'm going to go to the teacher and say, what color palette are you teaching these children? And the teacher's going to say, red, yellow, and blue. Welcome, red, yellow, and blue. Why is she or he teaching that palette? Why? Any suggestions? While you're pondering that, I want to point out to you this palette: cyan, magenta, yellow, MYC, M-Y-C. It's not yellow, red, and blue. Red. It's MYC. Okay? K is black. Ignore K for now. But this is MYC. Why are children taught RIB? Now you're afraid to say anything, aren't you? Somebody, that most people will answer that, except, and it was also brought up in the earlier class, but then the student said, yeah, but in the United States, it's true, and it's not true. Any thoughts? Any other guesses? You were taught RIB, right? Now, when you, as a kid, do you remember when you mixed red, yellow, and blue together? What did you get? Brown. Yeah, brown. But if I mix magenta, yellow, and cyan together, how perfect is that? Why this then? Why? Hannah, do you have any ideas?
The only thing I can think of is because it's like the standard
The
in a larger
standard.
number.
The standard. Well, I'm so glad you brought up standard. The word standard, because your standard so far has been to call this a color wheel. It is not a color wheel. But that's the standard. If I go online, if I go to Hobby Lobby, if I go, I could ask them, can I have a color wheel? And they'll bring over this circle with colors on it, right? It's not a color wheel. Also, this color, violet, you know it is purple. You know, it's a commercial word. There's a mattress named after it. There's a pill named after it. It's a word. But if I asked you all to go find something purple and bring it back, we would have 10, 12 different variations of it. Purple does not exist. Purple is not a color. Violet exists. And a violet is either a red violet or a blue violet, but it's not a purple. So standards have been overgeneralized and misused and misabused, as well as abused. And we need to straighten that out, okay? We need to standardize our standards. So, I'm going to give you 48 hours to think about why were you taught RIB, why are they teaching RIB in school today? And I'd encourage you to ask a friend who is a teacher. If you're still in contact with your kindergarten teacher, call him or her up and ask them. Ask your grandparents, what were they taught? Ask your mom and dad. See what you could find out. And then I'm going to ask the question again on Wednesday. Okay? But I want you to come up with a theory, and we'll discuss it further. I have a theory that I'll share with you. Okay? So far, so good? You thinking? Your homework is up, by the way. So on this palette, CMYK, if I were to make a shape, and give it, and so the color palette goes from 0 to 100 in the MIC palette, okay? It doesn't go from 0 to 255. Magenta, 0 to 100, and yellow, 0 to 100, and look at there's black as our color. How perfect is that? How incredibly perfect is that? So your homework is, which it has been open, and David, thank you for letting me know that, sometimes I forget. I do the 9 o'clock and I forget to do the 10 o'clock, but do continue to remind me, or to be on me to make sure the deposits are open. I did make sure today's deposit, this is open. And so on the deposit, I have 2 files for you that look like this. And so this is not a color wheel, okay? I'm going to show you a color wheel in just a little bit. So what I want you to do is I've given you your MIC colors, magenta, yellow, and cyan. And I created this template for you because I don't need you spending any time recreating this. I've already done it for you. If you pick up your white arrow tool, click on the wedge, and use your eyedropper tool, fill in the color with the color that it's pointing to. So this magenta is pointing to this wedge, and I'm going to fill it with magenta, and this wedge is being filled with cyan. So here are my primary colors, okay? What I want you to do is I want you to fill in the in-betweens. From here to here, here to here, all right? And then what I want you to do is I want you to identify each swatch by a number, its number in CMYK, okay? And the way to do that now with RGB, remember it was always R, G, and B numbers even if it was 0, correct? We don't do that here. If you look at the yellow, you'll see that yellow is 100% Y and you would write it exactly as at 100 wide. You do not do 0M, 0C. You don't do, if it's 0, you just don't mention it at all, okay? The magenta would be what? 100M. And the cyan would be 100C. Got it? Okay? Or C100, Y100, and M100. Got it? So put the numbers, the corresponding numbers outside of each swatch, on the outside, not on the inside. Okay? Clear? And then fill in the blanks and tell me what the numbers are. And once again, I want you to do this and tell me, is there a pattern to the numbers? Is there a structure? Is there a structure in which we could follow, and is there a pattern here? Okay? Questions? Nope? Okay. Once you do that, then I want you to go to the second file, which is going to be red. Red, yellow, and blue. What you were taught. And I want you to do the same thing. Red, yellow, blue, and I want you to, again, fill in the blanks. And I want you to tell me, is there a structure is there a system here? And then I want you to, when you come back, I want you to tell me what was the difference between Mick and Red. And which one do you recommend working with and why? Be very obvious. Yes, ma'am?
So on the second file, is it still CMYK numbers?
They're all CMYK. We are now all working in CMYK now. Okay? With the exception of K, you're not using K. You're just working the MIG palette, MYC. Okay? So you fill it up with your colors, and consider the approach. I want you to think about how you do this first before you get on start banging on a keyboard. And some of you are going to use math, some of you are going to use the computer, and some of you are going to use your eyeballs. I want to know which process works. I want to know what your process is for filling this out. So you're going to fill it out. It's going to look like you're going to have all the colors. Oh, and then once you get all your colors in, all your swatches, I want you to select the wedges and take out the outlines. Remember, because I don't want out. I'm giving you outlines now so you see where the wedges are, but once you fill it in, turn off the outlines of here, okay? Put your name up here and submit it as a low-res PDF file. These are called hue circles. These are hue circles, not color wheels. And let me show you what a color wheel is. Unfortunately, usually what I do is I have these toys in my office that I usually bring out and I play with them with you, but I forgot to bring them. So luckily I did videotape them or record them, so I'm going to play them for you. So you'll notice that there are color discs that had stagnant color, and when it spins, it mixes the color. You see that? A color wheel is a disc that spins to mix color. The whole idea, and during Newton's time, what they would do, the artists and the scientists would do is, hold on, I got one more. The way they would mix colors was by having a fan, like a fan stand with a pivot, and then after they would put a disc on it and spin the disc to see the colors mix. In Germany, during the Bauhaus, they would do the same thing where they would make these color discs or discs with different color distributions, like I have here. See all these different types of discs? And then what they would do, now these are not colored wheels, these are discs that would then go onto a child's top. And be placed on and then spun to mix the colors. So the standard was to take the spinning wheel and call it a color wheel and over generation to generation and just accept it as a color wheel, but it is not. Got it? So when we talk about the hue circle, some of you will make a mistake and call it, well, I made my color wheel, and I'll go, you're what? You know, it's a color wheel, you're what? Your color wheel. Your hue circle. So just get used to that, okay? It's not a color wheel. Got it? I think I have one more that I'll show you. And this one. There we go. You see how they mix? Okay. Oops. Any questions? Okay. Do you know what to do? No questions. Okay, so these are due as one low-res PDF file. The name of them are Hughes. Do MIC first before you do rib. Do rib last. See if there's a pattern to the numbers. I'm going to be really interested in asking you what your process was for resolving this, and were you successful? Okay? Anything else? Okay, thank you.